What's up, everyone? This is our product examination assignment, and we chose to analyze a hairdryer, and our team members are Keola, Maz, Zachary, and Victor.
I'm Victor, and we started by taking the hair drive apart, and there are many components, but we're just gonna go through some of the components. Here we have the main shell of the hair dryer. I believe is made out of ABS thermoplastic. I think they chose this because it's strong, lightweight, it can handle heat. The shell is produced using injection molding on a melt ABS pellet and injected into a precision steel molds that forms the entire handle and the body in one whole piece.
Hi, I'm Zachary, and this is the rear outlet shell of the hairdryer, which protects the wiring and supports the power cord. From its smooth, rigid surface, it appears to be a thermoplastic like ABS, selected for its combination of impact resistance, electrical insulation, and maybe even dimensional stability. Alternatives like polycarbonate could offer heat resistance, and others like polypropylene might reduce the cost but have less stiffness. Defined parting lines, ejector pin marks, and uniform wall thickness suggest injection molding was used. Injection molding allows for the complex internal geometry and consistent tolerances required for this housing, making it ideal for mass production.
Hi everybody, this is Maz, and I'll be talking about the heat shield. The heat shield in the hairdryer is made out of aluminum, which is known for being lightweight and having a high thermal conductivity, meaning it transfers heat quickly and efficiently and allows the heat to move away from the plastic body instead of towards it so the heat doesn't seep through. The most likely manufacturing process for this is probably going to be deep drawing, which is similar to how aluminum cans are made. In this process, a flat aluminum blank is drawn into a die and to form its cup-like shape, and then it's trimmed to its final size. Deep drawing here is ideal because it's fast and cost-effective and great for making large quantities of thin and smooth parts. An alternative could have been die casting, but the method would have been too expensive and slower for this kind of a simple hollow shape object.
Hello everyone, my name is Kale. I'll be talking about the printed circuit board. So starting off with the material, I have reasons to believe that the material is FR4 simply because we don't need a high resistance material to temperature, and we also don't need it to be flexible, which means that it's probably not polyamide or Teflon, which leads me to believe that it is FR4. Moving on to how the PCB is manufactured, it starts off with an FR4 sheet. And then it is thrown with photoresist paths on top and cured with UV light to carve into the paths. From there, it is then layered with copper wires to create your wires for connecting paths. And any excess copper wires that are on top are etched away. And then from there, to completely seal the board off, it is compressed, allowing for all the components to be in contact with each other. And that is how you make the PCB board.
Essentially, in this analysis, we identified multiple materials and manufacturing processes used in a hairdryer, including injection molding, deep drawing, and wire forming. Each process was selected based on performance needs, production rate, and cost considerations. Overall, this project demonstrates how thoughtful process selection can enable efficient, durable, and safe consumer products like a hairdryer. Here are our sources if you're interested in where we got our information, and thank you for watching.